Perfect. Yes. All right. So first of all, once again, thank you very much for letting us present some of the work we do in R. And today we're going to focus on how you can build interactive Shiny apps to share your work with anyone. So my name is Andreas Botten Smiby. I'm an environmental chemist and a scientific developer working at the Norwegian Geotechnical Institute. And with me, he is actually not so far away. He's sitting right there. He's Christian Mohr. Would you like to introduce yourself?
Sure, thank you. I'm Christian Mohr. I'm at the Norwegian Institute of Bioeconomic Research. I work as a researcher in climate and biogeochemistry, but focused mainly on greenhouse gas emissions from the land use change and forestry sector. So I know Andreas from university and also Raul, so we're a little bit of a community here in Oslo, although I'm actually stationed in Ås, which is about 30 kilometers away from Oslo. So yes, thank you.
And if you wonder if these are actually pictures of us, it is actually us shown here on screen. It's just pre-corona. Anyway, let's get started. So what we got to offer you this evening is we'll take you through what a short introduction. Why Shiny? Why work with this? Why do it? And then we'll tell you how to build your first Shiny app. And then Christian is going to take us through Shiny's little cousin called Flex Boards. And then we're stepping up a bit and doing advanced Shiny apps. We're telling you some secrets and some tricks. And then we'll round off and tell you how we put Shiny in production. All right. So then let's get started. So why Shiny? Why start to build web applications in R? So you have the classic one. You do something really great in R and you're super excited. And then let's say I'm the data analyst. I go talk with some interessents and I say like, you have to come see my new R script. It's going to make us world famous. It's going to solve everything. And then usually the reaction from the other person, it's like, R, isn't that some currency below equator somewhere? Was it Brazil? I don't remember exactly. Because often you find something really nice in R, but it can be really hard to share it and to get it out there. So I think that is illustrating. Often you can achieve a lot in R, but it's often really challenging to get it out there. And then that's of course where Shiny comes into the picture. So I usually say that Shiny, it's about putting your data analyst inside your computer. And then you can put your scripts on the web and you can give people a simple button to push. So they don't need any knowledge of R to share and to view your work in R. And then usually people tend to get more interested and it's much easier for them to access the stuff you do. So that's the overall setting for Shiny, I think. It's about taking the expert and making it more available. So overall, Shiny, as I mentioned, is the package to create the web apps from only R. Usually if you build web applications in other programming languages, a lot of people work in Python. They often do scripts in Python and then work with maybe React to build the user interface. In R, you can do everything in R. It's kind of a package which covers all the needs you have. So Shiny, it's started back in 2012, at least. That's when it was maintained by RStudio. So it started as a rough version, but it has matured a lot. And the nice thing is like whatever you put behind a Shiny, whatever happens behind the browser, it can be anything. Anything you can do in R, you can do in Shiny. So how does this look like? So here is the concept. The overall concept of Shiny is that you enable anyone to run R from a web site. So this is a very simple Shiny app. Usually you give the user the opportunity to give some inputs. So here the user can choose different index and different time ranges, and then you can do maybe some visual properties like smoothing, etc. And then when you give these inputs, this is sent to a server running R code. So it processes your inputs based on the already predefined data sources. And then it gives you some kind of output. And then you can present it in plots, you can export it, or you can present it in text, or however you like. So overall, what you can use Shiny for, I think it's very useful for insights. A lot of us working as data analysts, we look into data, we try to find correlations, we try to learn something, and that's a lot about insights. But in addition, when you also start to build the web application, you can also start to catch day-to-day data tasks. If you have a repetitive task at lab, for example, maybe you work with finance, you want to know the change in some stock markets, maybe you want to compare different data sources, and maybe you want to couple up with some precipitation models if you're looking at the electricity prices, especially in Norway, we have a lot of hydropower, etc. In addition, some of the beauty of Shiny is so easy to get going. So a lot of people use this for prototype. If you have an idea and you want to test it, Shiny is a very good tool because it's so easy to get going very fast. So before we dig into some code, as I mentioned, we'll take you through how to build your first app. I'll just briefly show you some demos. And the first one is actually a submission I made with a colleague here at NGI, which is about 3D interpolation from points measurements to full grid. So as we said in the intro for this talk, we're going to do mostly examples from biogeochemistry. So this is actually a polluted site in the Netherlands where it's taken samples in different soil layers, maybe at the top level, then they dig a bit down, take another sample. But often you want to know how is this in, how many cubics of pollution is there? So then you need to have some interpolation to go from points to a grid to show the total 3D surroundings. So then I'm going to leave this and I'm going to jump to my browser. So then I just go to a regular URL. So now we firing up our server, and then it gives you a welcome. It gives a brief introduction about the app, and it says that you cannot sue us if you use this and you didn't like the result. In addition, you can also find the code for this one on GitHub. So this app is built up with different panels and different tabs. So as I said, just to get started, you will go to load data. So a very nice thing, often when you build some Shiny apps and you do R, it's often really nice to provide people with some test data. So that's what we've done here. So you don't need to have your own data, but if you want to use this for the analysis, you can also upload any file from your computer to the server and you can run your own dataset. But for now, I'll only show you the test data. So then what's nice with Shiny is like you can go in, look at the difference, you can get some information. Maybe you thought this figure was so interesting, you want to share with a friend. You can dump it as a picture file and send it on email. Or maybe there was some measurements, maybe measurements 126 was particularly interesting, so you wanted to check that out. You can search it up in the raw data table. So this is a very nice way just to get the hold of your data sets. So when you're happy about your data and you're ready to start to do some modeling, you can go continue on to the next tab. So when you want to go from a point measurements to a grid in 3D, there are a lot of different ways to go. So this has been, we discussed this a lot at NGI because we think this is really interesting and a very nice case. So what we've done here, we put up a number of different deterministic interpolation methods. It just means it's an algorithm. You don't need to think about what it is. I don't think it's important for this talk. In addition, we also add some geostatistical methods called ordinary kriging. So what we do then is like we do cross-validation. If we have a dataset with 100 points, we play hide and seek with our datasets. We take 1 point out, we use the 99 remaining to guess the value of the point. And then you get the predicted and observed value for each data point because you work your way through your entire dataset. And in that way, you know the error of your model because you know the difference between the observed, the true data values, and the predicted from your model. And then you can start to compare different methods. And we see that for this test data set, the winner was the geostatistical method, the ordinary kriging. So then this is a very nice way for people just to get an overview of the differences between the methods. And then in addition, if you want to dig in more, you can go and dig the difference for the predicted values for each of the different models we run. You can, of course, also export this to Excel, or you can take it over to R if that's what you like. And then to complete, so the Shiny app is supposed to complete the workflow, and then we need to visualize the grid. So visualization of 3D dataset is not so easy. So, and we ran out of hours, to be honest, in the project. So we did not have time to do anything else than a 3D plot. So it takes some time to render this because this is on a test server, so it's not the strongest service we have. At least here we have it. So if you look at this method, for example, so here we see that all the different points, and then we can also look at the estimates. Oh no, it actually froze. Yeah, it had to happen because it's a demo. But anyway, you get the points that here we then can view the results. Interesting. So that's the point of this Shiny app. It takes you from, oh, it was just a bit delayed. Maybe I pushed a bit too many times, sorry. So here you see for some of these methods, it's higher variation. We can see the values here. It differs. And then you can also view the different estimates. You can take the data further, or you can expect some of the details, look at the histograms of these estimates to compare why are the differences between these methods. But the overall take-home message that we try to do with this Shiny app, we try to make a very specific problem, which requires a lot of analytical knowledge and expertise within this field. We try to make it available. You know, I was just pushing the buttons, and it takes you through. And another aspect I did not show you was like you can also add some useful tips, because it can be really hard to know when you're sitting working as an analyst. It's also very hard to know how should I handle this value. So that's a nice thing with Shiny, that you can put up graphics which helps your user. This is not so easy to do from R. So we do that when it's hard to know how to choose.
Andreas, there's a question that just came up in the chat. And it's, is there a limit to the number of rows this model can take? And in general, a Shiny app?
Yeah, so R, it likes memory because R, it eats a lot of memory. So how this app is written, it will reach a limit because we're not going to serve everyone for 3D. So I think it's like 1,000 lines or something. But in general, you just have to be careful with your hardware, right? You need to have enough memory, because if you hit the roof of your memory, then your app will crash. But I'll show you some tricks when it comes to the production and how we can avoid hitting those roofs. So stay tuned. But thanks for the question. Just keep adding them, Arrow. All right, but then I hope you get the overall data flow and the meaning of the concept of these Shiny apps. It both gives you the opportunity to learn something, and in addition, it gives you enough tools to finish a data flow. I would also just like to show you another one, just to give you a bit, that was a very specific case. So now I'm firing up another server. So we do a research project together with Army's real estate agency. That's the owner of the Army's pollution in Norway. And of course, shooting ranges, there are a lot of bullets left when the Army are done playing around. And so this app, we are investigating different shooting ranges and how we can map them and do abatement actions to reduce the runoff of pollutants. Stuff like that we think is really fun at NGI. Then usually we attack these kind of problems in R&D projects from many different angles. And then I think Shiny is a very good way to communicate how we're working in this kind of projects. So we have, we try to combine the different results we have in these projects in this app. So here, for example, you see there's a classification, which is data processed with machine learning from drone imagery, which we use to see which part of this is actually peat underneath, which is severely damaged. You see them, there's a lot of bullets being going here. And then we can use this imagery to classify and see how big a percentage of this peatland is damaged. And then in addition, we can add some in situ measurements to see if we were right or wrong. So the current conclusion is that we need to do more work here, because you see it's no obvious relation between the lead measurements, which is the main pollutants in these systems, and the classifications we done. We don't have so much data yet. This is an ongoing project. And one of my favorites is like a lot of people, they do regression, but it's often very hard to know how good is this regression? Are there any correlation? I don't actually know. And at least I think in many fields, often you just compare two parameters. Do they tell the same? And how strong are they correlated? And then usually you just put up a correlation plot like this, and then you plot your R squared and you look for your p-value. But then what's nice with the Shiny is it's snappy, right? So you can just change the values. So now I changed the maximum concentrations. I threw out an outlier, and then I see all the value changes. But I think this audience is very digital literate. So I think you see there's a banana curve in my QQ plot. This is no good. But then at least I can explore my data sets. We have a lot of parameters to compare. So you can do this very snappy, and I can also play with the other partners in the projects, and I can send them here to watch different correlations, and they can also do this analysis, which they could not have done in R. Moving a bit on, we also work with drones and precipitation and watersheds. So 3D is becoming more and more important, and I think people aren't aware of how strong Plotly and some of the tools are becoming now in R. So this 3D model originally, I think it had 1 centimeter resolution, but we downscaled it to 10 centimeter to make it faster. But even though for us this is really interesting to compare the curves around our sampling points to see where is actually the water coming from for the different sampling points. That's what you're seeing here, and then we divided this shooting range into different zones. But anyway, it shows you at least that the 3D capabilities now of R they are improving. And then the last thing I wanted to show you is like GIS also with Leaflet is also becoming really nice. You can add pop-ups, and you can also connect this to different filters. So you can choose, let's see, I only want to focus on some lanes, and then I can get all this sampling points, but I don't want their name because there's so many, and then I can have their results here. And you know, this is Plotly, so it's interactive. You can zoom in to your favorites, and maybe you only wanted to look at one parameter. Yeah, I think you're getting the picture. It was not maybe the best example. If you get lost, push home. Yeah, but at least then you see that this is also useful for time trend analysis, where you couple plots with maps. So I think I'll leave my demo there. I can send you the links if you like to look at this and afterwards. So then I'll jump back to my presentation. Yeah, so I just show you this. This is actually the kind of cameras we use. It's multispectral imaging, which gives much more information than regular drones. So it's I really like this stuff. Yeah, and some other cases we've been using Shiny for at the NGI. We have been using it for some prototyping. We have been testing sensors, and it's really nice just to put up dashboards in Shiny because it's so fast and easy. And we've also been working with satellite data versus ecosystem services, which is when you want to look at an area and want to know how many kilos of carbons are stored in this area, what is the land surface temperature. This is the screen up you see here. We also have been doing that. And we've also been using Shiny for teaching with the high schools we cooperate with and the universities where we have our master students. So that was some of the width. Is it okay this far, Christian? Thumbs up from my side, from our wingman. All right.
Andreas, if I can just ask, there were a couple of people that were interested in getting the links to the Shiny demo you showed. If you maybe could post them into the chat later on, that would be great.
Yeah, and I think we'll just push this to the repo on GitHub. You can have the presentation as well, I think.
Yeah, perfect. Thank you.
Yes. All right. So then I think it's time to create the first app. So I'm gonna do this semi-live, I would say. So the easiest way to get started with Shiny is, of course, downloading RStudio is a bit easier than RBase. But if you go to new file and you ask for a new Shiny web app, it actually gives you a template. I'm not going to do it now because I cleaned it a bit. But if you push create now, it gives you something like this. And let's look at it first. We can just run it from within R. We don't need anything else. So if I push it now, it pops up. And we get the opportunity to look at Old Faithful frequencies, the Old Faithful data sets and the histogram, I'm sorry. So this is a very simple Shiny app. It just has a slider. You choose the number of bins, the number of groupings on the x-axis, and then it updates. So that's the concept behind this app. So then first I'll take you through what is actually going on behind the scenes in this code. The first thing you need to do when you build a Shiny app is to set up your environment. So the first thing, the first part of this Shiny app is the global part. And for this app, the only thing you do is to upload the Shiny package. The next thing you need to do is you need to construct a user interface. You need to tell Shiny where do you want your buttons, where do you want your plots and text to come out. So then you need to use a template. So fluid page is one of them, dashboard page is another one. And then you can, for example, use the functionality to insert a title panel. And then you can use a template to split your screen into a sidebar panel and main panel. That's you saw the inputs. I'll show you soon again on the left, and then you have the plot on the right. The result that's the result of using this template called sidebar layout, because on the main panel, on the other sidebar panel. And then here you define an input, which is the slider you saw. So this just tells R what is the input variable which will be available on the server side, and what's the title to be shown to the user, and what are the values. And then the last part here is you telling Shiny where do you want to put up the plot. So I think what's really useful sometimes is just to run this code without storing it as a UI. You see actually what it is. It's just an HTML wrapper. So because a lot of people using R are not very confident in HTML, and I think also this is much cleaner to write than this part, and this is very useful. So all it does, it wraps up HTML code for you, so you don't have to deal with this. And then, as I mentioned, you made an input, and then you had an output here, and that's the inputs your R server want to know about to make the outputs. So you tell it, these are the inputs my user made, and he wants this kind of outputs. So in this case, we only wanted that plot. And as we see that the input we defined was called bins, and we find out here, and that's defining the length out of the number of bins used in the histogram. So then if this changes, then you see the bins variable will change, and that will affect the histogram, and that's what you're observing when we run this app. Show you once more. So the first thing we did, we defined the title, and then we made a sidebar layout, which made a sidebar panel coming up here with an input. And then we had the main panel, and then telling it was gonna come a plot here. To make the plot, we sent the input value, which was 30 in this case. It was put into this function, which defines the number of bins used in the histogram, and then it was sent back through this server function to the UI, and this plot came out. So that's the basic concept of a Shiny app. So then I thought it would be nice just to get you a bit more aboard to add some stuff. So then I thought I would add the first thing I will do. Let's say we want to look at the old faithful datasets, but in addition, I'm super into the cars datasets. So then I want to be able to choose between two different datasets. So then I added a select input. That will be a drop-down list where I can choose between two values, which will be the old faithful and the cars dataset.
Andreas?
Yes.
There was a question, or a request, I should rather say, if you could increase font size, maybe a bit.
Yeah, of course. Let's do Control+. How is it increasing? It's better?
Yes, That should be all right. And there was an additional question just now. On the server side, or in the server function, I should say, why do we not have not feed the input, how it takes the input itself?
Yeah, so that's what's actually makes Shiny a bit different than React and JavaScript and other languages one often use to create the application, because that's the kind of the magic with Shiny. It does all that kind of work for you. So that's lowering the bar to create the applications, because that's just predefined by using these templates for these inputs. It's just by magic. That's the short answer. But if you dig into the code, you will see that actually here in the end is where you run the code. So that's when you're putting your UI together with your server. So by default, all the inputs you define will be input, and then there will be a sublist within input, all the variables from the UI. I hope that was understandable, but at least that's some of the stuff the Shiny package does for you. So all inputs you define in the UI will be available on the server side. So now we also wanted to have the opportunity to pick another dataset. We're getting tired of the Old Faithful, but we still want to keep it on board. So we want to have the chance to regret our choice of only looking at cars. So then we put up another input. So if you just run this now, this will be how our app looks like. Now I zoomed a bit, that's why the layout changed. But now you see this drop-down list, we can choose between the two of them. But nothing happens, right? Because we have not defined any action from this input, which is called select datasets. It doesn't do anything now on our server side. So we need to put in some action on our server side. So then if you have two inputs affecting the same output, it's often recommended to make a reactive. And that's what I put in now. So to have the current datasets, I make a reactive function. And reactive is a special kind of function within Shiny because it handles the dependencies. Because if you change different inputs, it's going to be some sort of pyramid game in the end, where a lot of things are going to happen. And I'm soon going to show you how this works behind the scenes. But now at least, I defined this select input, which was called select dataset, and you can choose between the Old Faithful and cars. And then you see that if you go for Old Faithful, you get the faithful dataset, and if you go for cars, you get the empty cars dataset, and then the cylinder volume, I think, is the column which is chosen. This reactive then returns the datasets. But now there's no connection between these two code chunks, so that needs to be fixed. And that's what we want to do now. Now we're going to exchange the X in this function was the dataset. So now we're asking it to go up and check out this code chunk to get this data when it wants to render this plot. And then I think we should be good. So then we'll fire this up again. I have to stop the old one. Let's see. And now if I change the dataset, you see that the plot changes, because now it shifts the dataset based on the second input we made, which was the select dataset. So that's a very easy way to change the data. But the nice thing is, because this input, which is the number of bins, is led directly to this part, it does not affect the execution of the dataset. It does not have to run this again if I change this. And that's called lazy programming, because you only want to run the lowest amount of code at all time to save capacity. So this reactivity thing is a bit tricky, and my co-developer at NGI, which I've been working a lot with Shiny with, I don't think he loved the reactivity straight away, because this is a bit tricky. What usually helps a lot is like if you add a little developer tool called React Log, it all becomes so much clearer. So let's add React log and then tell Shiny to log everything happening between the inputs and outputs. So then we'll stop it again and we'll fire up our app one more time. And then let's say we do some stuff and I look at this and I change this value once again and maybe one last time. And I just push Control F3 on my keyboard. And then I get to have a movie night with the reactivity of my Shiny app. So now here you got, okay, so this was maybe a bit hard for you guys to see, but here you see the input of select dataset, which was original all faithful. This input affects the reactivity called dataset, which then affects the plot object, which then is sent to the plot output. So I think you, so when you affect this one, behind the scenes, it changes the dataset, and then it affects in the end the output, which is the plot. So then if you want to know what happened when, then you see that someone pushed the select dataset was changed, then this is invalidated, and then you can see how this affects your app. And then you can follow each step Shiny was running behind your behind the scenes. And then, so this is a really nice way to see how things are changing. So now we see I changed the number of bins. So then this gets invalidated. So then it needs to run this in these sequences. And it's also kind of nice. Why is it not showing now? You can also see here the amount of seconds or milliseconds it takes to run. So in our case, it took 72 milliseconds to run the plot objects. So obviously it's not so interesting in such a simple app. This is also a nice way to get some sense of the profiling of your app to find the bottlenecks where does the code spend time. So yeah.
There was a quick question here because I think not everyone got how you got to this view that you have now.
Yes, I pushed Control F3 on my keyboard. So that's, you just have to remember to put up the debugging options first. And then you just fire up your app. And then when you are running your app, you just push Control F3 and then it directly pops up another window. There's nothing more fancy than that.
Wonderful, thank you.
All right, so then we have made our first app. That's achievement. And then I think we'll expand this app one step more, and then I'll give it to you, Christian. So Old Faithful and cars are interesting data sets, but there are more data out there. And I think some of the beauty of Shiny is to integrate towards external data sources. For example, meteorological data sources, or maybe some finance from Google, maybe some statistics from some statistical bureau, etc. So I think the next demo I'll do for you. Let's see if I can change my RStudio. Where did you go? Okay, so that's the second. So now I think, so now the goal is to take our app and go from this Old Faithful and make a meteorological app which can show which can forecast the temperature the coming 10 days using the YR, which is the Norwegian weather forecast services, to predict at any location of the Earth the coming temperature the coming days. So I think we'll just stick with our Old Faithful. So first we'll just change the title. Let's call it the weather app. And then obviously we don't want this kind of inputs anymore. We want to give it some coordinates. So what we'll do then, we'll just now I'm defining something called numeric inputs, which is just that you can push in a value. And before I forget, we also need to change our environment slightly. We need some more packages. So we'll use Shiny and we use the HTTR package to interact with the APIs to retrieve data through the web. And then we use Leaflet to make maps. We use the XML map package, to extract our data from the response we get from the API, because we get an XML file. And then in the end, we use shiny themes to make it look a bit cooler than the default look, but only a bit. So a very nice way just to get some color on your app is to add the theme argument. And then if you use shiny themes, you don't have to do anything yourself. You can just use, for example, the superhero theme. So we'll keep our plots, but in addition, we wanted to add a map. So then I'm adding a leaflet map to this app. Yep, that looks great. So that's another output, kind of output. Here we had a plot output. Now we're making a map output. So for this dataset, we just loaded the faithful dataset and the empty cars dataset from memory because it's built in base R. But now we want to step up and we want to get some data from an API. So this part of the app, I'm not going to go into detail because it's not the topic of the day to do web scraping. But anyway, I'll give you the brief details. You should just feed the base URL for the API. And then you paste in the lat and long, the position you want to know the forecast to run the model, which is behind the API. And then you do a GET request. And also really important when you do shiny apps, you should always consider what if some things go wrong. So that's why I put in a try. It just means that if this code line fails, it will just return a null. It will not return an error. So that means I can end this function and get out of it with a null value. I'll get back to why that's important. And also, if this API tells me that something went wrong, maybe I managed to connect to it, but it sent an error message back. I just want to abort. I want to get out of it with a null value from this function. So then we know that if you reach line 41, you have some proper data. You don't have any error messages, etc. So then the first thing you do is you parse your XML file. I'm not going to go into detail. There are nice packages to handle this in R. And the response we get from this kind of API, this is a bit topic specific, but it gives a lot of different values. So I'm just picking out the temperature and the time for the temperature reading. And as always, be picky about how you format your dates in R. Otherwise, you'll be on thin ice. So that's why I'm throwing out some letters which they put in to the date string, and I just make it a POSIX CT, and you're good to go. So then in the end, this data set now just calls this API, uses the inputs, the location you defined, and throws back the coming weather forecast for that particular point. So, but then we also need to edit our plot slightly, because now we're not gonna do a histogram anymore. So I'm changing it briefly. I'm still asking it to go to dataset to retrieve the dataset. But now I'm adding a statement that if dataset is null, you can leave. It means if you did not get any data from the API, there will be no plot. And then I just tell it where in the dataset to find the X and Y coordinates, and then I will just make a simple line plot. In addition, we wanted to make a map, and that's very easy to do in Leaflet. So we wanted to use the Leaflet package. There are also different alternatives, but this is maybe the easiest one to get started. So when you make a Leaflet map, you just call the Leaflet base map, and then you can add different background maps called different tiles. And then we wanted to know where did we find this fantastic weather forecast. So we want to know the location of our forecast. So then it's always exciting when you make changes to our app live. So let's see what happens. And we were lucky. Or of course, that was not lucky, that was precision. So what we see now, that we added 2 numeric inputs, which was the latitude and longitude. That's what we did here. You see, I gave it some default values, which is in the Norwegian mountains. And then we asked it to put up a plot called this plot, and we asked to find the output map. And that's what's been showing here. So what's nice now, this is interactive because this is leaflets, so this is alive. You can zoom and wander around. So now we see that this dataset, it ran fine because the data reached the plots. So this is now kind of snappy. You can just move around. If you want to change plots, maybe you wanted to go somewhere totally different. So now we're actually, where are we? We are almost in Antarctica. So it's not going to be so warm there the coming days. But at least now you see the concept that is very easy to connect to external data sources with Shiny. And you can make it look kind of decent, quite fast using this themes argument. So do you want to tell something more about the flex boards, Christian?
Yeah, thank you, Andreas. You put on mute, right, on your side? Stuart. Yeah, thank you. I think that was a really good overview of all the possibilities from Shiny. I am now going to, I would call it, take the amateur road to doing Shiny when you have, in my opinion, very little experience with Shiny and want to do something quick and interactive, but have perhaps limited time, and maybe you just are fairly new to Shiny and you just need to present something very quick for some colleagues. And I think this is really where Flexboard shines. No pun intended on the Shiny part, but so what we're going to do is I'm going to demonstrate setting up a Flex dashboard, which is our Markdown document. So let me just share my screen here. There we go. Here we go. So Flex dashboard is a Markdown document. If those of you are familiar with Markdown, it's a text editing, or it's a code-based text editing documents, like similar to what maybe some of you familiar with, like LaTeX, and where you write code and then you can produce documents either in PDF or Word or HTML. And the usual step is you would choose a document, or you can choose a presentation, and you would then be able to create these documents in whatever format. What we're going to do here is we're going to go from the template and we're going to pick something called Flex Dashboard. Now you have to install Flex Dashboard beforehand to have this option. And then once you've installed it on your machine, then you will have this option in the template. So we'll click OK on this.
Christian, and just a sec, if you could also zoom in a bit and increase the size.
How's that?
That should do it. Thank you.
You want one more size?
Yeah, you can try one more. Yes, excellent.
We don't need this side here. So the Flex dashboard is already, here's the sort of template. It's already set up. It loads in the Flex dashboard, and there's a bunch of parameters here, like the title of the document and so on. And then you come to this part over here where you start seeing where it says column and some lines, and then there's this chart, and then there's some R code, R chunks here. And if we run this script here, we'll have to save it first. So I'll call this just demo. Now it'll go through an R Markdown compiling of this document or this script. And we end up with something very similar. I'm going to zoom a little bit, where you have the title that we had before here, Untitled over here, and then we have this chart A, chart B, chart C. And as you see, it's split up in this format here based on the information that we've provided here, where we've explained that we want a column. We're doing this by column orientation. So we say, I want a column here, and I want a column here. And then what are you going to fill into that column? And so we filled in chart A, and then whatever code we're going to have put here. And then same thing on the next column, right on the right side here. We have this column here, and in that we have put chart B and chart C. So already from a very simple script of only 35 lines, maybe we can cut down a little bit here. You've already set up a layout of a dashboard where you can then put plots that you can then show to others. There is also possible to change the orientation. So if you want to work rather with rows, that can be handy. So if we just, let's see what we can do, we can change this part here to rows, and we're going to also have fill. And then we are, instead of going to write column here, we're going to have row. And then, we can keep the height the same, and we can do row here. So now what happens if we run this code? You will see that it's now done this row by row. So this is the second row, this is the first row, and then whatever you put in the row is what you want to show. And so for this demonstration, I work, as I mentioned, I work with greenhouse gas accounting. So I have put together some data, compiled some data before to make a database of greenhouse gas emissions from a number of countries. These are technically called Annex 1 countries. These are most of the developing world where they do greenhouse gas accounting every year. And what we're going to do is we're going to present this data, perhaps maybe for a colleague. Maybe you have to send in data to the ministries or to some consultancy firm. And this would be a nice technique then to present that data. So I'm just going to show we'll just take a demonstration of this here. And so here I've changed the title. Now I've called it Greenhouse Gas Accounting for Annex 1 countries. We're going to use this row setup and fill it. I've also there's also option for themes, so you can change different themes for the document. And then there's some additional editor options, such as if you want to, when you're working in the document, if you want to see it in your console being here, or whether you want it in line as you sometimes have it in Markdown, where you see the code coming up for individual lines. We are loading, we still have our Flexboard. I'm putting in the Tidyverse package. There is this knitter package, which is useful, that we're going to, when we sew this together or put this together, compile it, it's going to use this knitter where we choose what kind of, usually would choose what kind of document type we want out, such as HTML, Word, or PDF, but in this case, it's all HTML. And then there's a few packages. You can always search these up. There are different types of packages for working with geospatial data. We are going to produce a map. So we need some spatial data that we're going to work with. And then, because I don't have maps of the world, there's some nice libraries that provide you world maps and where you can provide the country, etc. And we're going to then join the tables that I have compiled for the different countries with this spatial data. So the first part, obviously, is that we will run all these packages. And then
there have been a couple of questions just now.
All right, yeah, maybe we can go through quickly. Is it something?
Not just very short questions here about how Flex dashboards compare with Crosstalk, if you're familiar with that.
No, unfortunately not.
And if anyone in the audience is familiar with Crosstalk, please post it in the chat. And there was also a question, is there any form of manual or cheat sheet for templates for Flex dashboard. And
Absolutely.
I'm sure there is.
There is absolutely. If we go conveniently, I have it already up here. Is the screen still shared? Do you see a website?
Yes. Yes.
Yeah. So this is where you can do tutorials, and one of the first things that they have is the layout. So how you would like to set it up in regards to charts, and or if you want rows, and there is. Sorry, we have a little bit of alarm here. So and there is also a lot of options. So Flex dashboard is quite flexible. Again, no pun intended, but there is tab sets, so you can have tabs instead of charts. So this is actually it's very good to take a look at the tutorials, especially for the layout, so you can then design what kind of layout you want. And then it's all about putting in what you want. There is Leaflet, there's digraphs, which are typically used for well, time series data, so particularly financial data could be good, but anything where you need to work with time series, and then you have these already ready packages which deal with dates and times where that sort of stuff is necessary. And then there's a bunch of other ones that you can take a look at. These are Plotly, higher chart, yeah. And then there's galleries, obviously, that are worth looking at. And then we'll come later on to the shiny part, which is then implementing the interactive part. So take a look at that. That you just basically, I think the easiest is just to search Flex dashboard on the net, and then you should find this. So it's again, one of the nice things with Flex dashboard, it's fairly easy to start using it. There's not a lot of threshold. As I pointed out here in the demo, it's basically you use basically lines to split, so it's very visually easy to understand what's going on, and then you have the chunks where you put in your code to visualize some plots. So that's what we're doing here. I'm first starting with loading in data. I have already compiled a table which is in this tidy format, long tables. And before I have to do some cleanup, and not since mutating any data, but we can't have, for instance, the European Union and at the same time aggregate on other countries, so we don't double account for emissions. And then there's a few things where in this table, there's some totals included plus the under categories. So I'm removing the totals so that we can do some aggregation in the scripts where we're processing the data. So the first thing is maybe to use the first column or row, sorry, for a map. And in this case, I'm basically taking this. Let's run the script again. So we have this table here. I'll share it a little bit like that. So here's all the years, and then there's the different sectors. And then here are what they refer as IPCC categories. There are categories that are sort of subcategories under these different sectors. And then here we have the emissions in kilotons CO2 equivalents. And then there is a country code, which will be useful later when we need to match it up with the countries. It's always better to use country codes than the actual country name, as there can be slight variations in how people write the names, or whether they use official names, and sometimes there are unofficial names, etc. So this is basically the table, and it's a fairly large table. But we are going to, first thing we're going to do for this table is we want to create a map with the mean greenhouse gas emissions per capita. And so the first step we're going to do is we are running the script here, which is going to then group the data by year and country as to get a sum up all the emissions for the different sectors. Then the second step here is we're going to take the values for each of those years and group them by the country to calculate the mean emissions for each country. And then there's a little thing here which is very confusing, but this is the variable that's going to join up with the map variable that we're going to get from this package here called R natural earth. So we run this here. We're going to get a new data frame that looks like this. So it's a small data frame with where we have every country code and the emissions. And I've transferred the data into gigatons because when you start working at, when you start taking into account all emissions, you start ending up with fairly large values. Then we're going to use this package, this N natural earth, and we're going to get the countries, or get a map, so we can get spatial data in this SF format. And the SF format is quite nice because it's a table at the same time while it has spatial data connected. So you get the spatial data, but you also have this data table connected. If you type class, for instance, we write world. There we go. You will see that it's both an SF and a data frame. So, sorry, not data table, data frame. And so the advantage of this is you can still do tidyverse or dplyr and tidy operations to mutate to manipulate data. And so we have now created this, and now we are going to join this map with this data that we had created for the global greenhouse gas emissions. And as if you remember, we have this variable here, GUA3, and if we look into this one here, we have that same variable here, where it has all the country codes. So we are going to join those together, and then we get this new object, which then has our greenhouse gas emissions. Now, there's a lot of NAs here because we don't actually have, we only have emissions for Annex 1 countries, which are basically most of the OECD countries. So they're largely the developed nations, which can do this sort of yearly accounting, which many other countries don't do. They do it maybe every fourth year, and they have slightly different categories. That's why I'm only sticking to one set of data. Right, then we are going to use now this data set, this world map actually has some statistics as well, like GDP, income, and so forth. So we're going to use the population. Now, this is not exactly a perfect situation because population changes every year, and we are just joining it with the last census of the population estimates that are here. They're actually in a text format, so I have to first convert it to a numeric, and then we're going to divide those emissions with the population. Again, now I have to go up again to tons because it becomes too small, and then we were going to get these emissions as tons CO2 equivalents per capita. And now we are ready to plot it. So let's see how that looks. Maybe I'll do that one more time. I'm not sure, maybe it's because I've zoomed in too much. Sometimes there's an issue with the plotting. It's a little bit. There we go. So here's a typical ggplot map where we've plotted all the countries, and here we get an overview of the tons CO2 per capita for different countries. And here you see all the Annex 1 countries. Good, then we've done that. That's a map of the plot. You can always change the parameters. This is more of a ggplot-ish thing, but that's basically what we've done. We've created a map from that. Now we can go to our next chunk, which is we we started on, we have one row here. So in this case, I've actually split the first row into for 2 plots. So the next plot is to produce a bar plot, and I'll skip ahead here. We're basically going to group and summarize and all the usual, and then produce a plot, and that's going to look like this. Here we have a time series. This is a bar plot where you see all the different sectors aggregated for all the Annex 1 countries on top of each other here. And you have your one area, the area I work in, which is the land use, change and forestry, which is a negative usually source, because forest trees capture CO2. So when you account for the forestry, you usually have an uptake versus the other sectors, which are all positive emissions. Good, then we want one more thing, and that is a nice table. And now that won't be visible here, but it'll be visible in the console here. I'm going to use this cable, which is this function from the knitter package. And we're going to run this, and then we're going to get this table here. But the real, it will look nice, a lot nicer once we knit this whole thing together. But that is basically it. We've used now those 3 different blocks, and we've put in a table, a bar plot, and a map. So let's see what happens now when we put this together. So here we go. We have a little different theme than the previous one. This one seems to light up when I put the mouse pointer over it. There's a bit of a weird thing going on here. That may be actually because I had put, I'd written a bit of code here for the class. That's obviously showing in the background, but we can remove that or delete it. And let's go back here. But here, other than that, we have a map, we have our bar plot, and we have our table where you can see the data for each year. Great. The nice thing now with this is that we can share this. So if we go into our Flex dashboard folder where we're making this document, we have a HTML file. And we can open this in a web browser, and here it is, ready. You can send this now in an email to a colleague and so forth, and they get a nice overview of the data. It's a very nice way, without having to write an actual document, it's basically a nice way to visualize the data and show your results. Let's go back to our, So now the next step here is maybe we want to look maybe at a specific country, maybe a specific sector. So let's say I want to look at Norway, and I want to look at the land use, change and forestry sector. So I'm just going to go get the next file. So we can edit this. It's a very simple process, and where we would filter out what we need from the table, and then we would replot it. So if we get that document, let's put it here. Same procedure. Now we're going to go for the land use, change and forestry greenhouse gas emissions from Norway. We're going to run exactly the same code, but where we're going to change it up is that we're going to start filtering out for the LULUCF sector and the country code Norway. And then we are going to run this script and get only the data for that specific country and sector. We'll do the same thing for then the bar plot, where we'll select out what we want, produce the bar plot, and same thing for the table. And here we go. Now, the map is not so useful. We only have one country. So you only have one big bar and the rest of the countries are gray. But we get now to see the trend for the LULUCF sector, the land use change and forestry sector. I've also one thing I did change in the code is I actually grouped by then these IPCC categories, since otherwise we would just have one bar. And then we have, again, the data here in the table, which has done the same thing, which is grouped by this IPCC category. But that's really as far as you start coming with Flex Dashboard. This, again, you can send to a colleague or a friend or anything work-related. But this is a bit of going back and forth. Maybe you want to see France, maybe you want to see a different sector, and you can change out the code and so forth. But that's where it starts becoming a little bit impractical. And that's where Shiny comes in, and where we can then use this procedure where we use Flex Dashboard, but we apply then Shiny code in addition. And the very nice thing about this Flex Dashboard and Shiny code functions that you can apply to it is that they are a little bit more simpler in the programming style. So let's take the example, which is basically based on this one. And now what we're going to do is we're going to add this line here, this what says runtime Shiny. We're going to add this, and we're also going to add the Shiny library. This will then change it. It will no longer be a knitter, and you'll see that now it says run document. Now this is going to run like an active app that's on your computer. So that the sharing possibilities are not there in that sense, but unless you have it over the web on a Shiny server. And so in this, what we're going to do in this case is we're going to load the data same as before, but here I've done a few things. First, we're going to make some sector options. So if we want to pick out different sectors, we would like to have some choices. So from this table, I'm going to find all the sectors. Going to use unique and then find them as character, and then I'm also going to add all. Now there's nothing called all in the table, but I'm going to add this at a later point because there could be times where you want to see all the data, and there could be times you want to see a single sector, and so you need that option. And then here comes the part where you need a part of our table. So we would like to have a sidebar here where we can then put in our data or put in our options and make our selections. So we use this input sidebar, and again, we use a sort of line. The rest is the same, but now what we're doing is we're putting what you also saw from what Andreas presented. You have these Shiny functions where you then provide what you're selecting and your options. So here we're getting those options for the sector from here. And that's going to be our select input, or what we're going to call it cell, the input for select sector. And then what's also nice is if we can have a slider to choose how many years we want to see. Maybe we don't want to see all from 1990 to 2018. So 2018. So we can use this slider, and you'll notice that unlike sliders can either be like you can have one slider. So if you want to pick out one value, but in the case of years, you want to pick a range. So the value then will have two values, one for 1990, 2018, and we'll have steps of one. And then we have a drag arranged set on true. It's also rather important when you're dealing with years that you put this here. It's only to make it understand that this is years and not just some number. If you don't have this here, you'll see sort of 1000 and then a sort of apostrophe and then 990. So it's just sort of like the way you would present sometimes numbers from 1,000 and a million and so forth, where you use those divisions to separate 1,000 from 1,000, million, and so on. So by doing this, it actually becomes presented as text, but actually behind it's still numbers, and that's rather important because we are going to filter out by numbers. Then we come back to the same code again here, but now there's a little bit difference here. Now we have to have this render plot function from Shiny. This is so that there is a reaction to when we make changes in the slider input, that they actually make changes in our plot. I also have to do a few things because we have all. In that case, we want to aggregate all the data. And in the cases where we don't want to use all, when we pick something else, we want to filter it by that sector. So we have two, we have a if-else statement to separate the two. Other than that, we continue with the produce map and we get a nice map like before. And then we're doing the similar thing for the bar plot. Again, we separate between all and for the all option and individual sectors. And we do the same thing for the tables. So now if we run this document here, fingers crossed. Let's see if it's running behind here. If it's still not finished. I see it's got some issues here. Let me just check that it is getting the data from the right place, because that is sometimes an issue. Try again. Yeah, maybe we go to the next one. I'm not really certain why. We try one more time, see if it. Yeah, so this is actually a bit buggy. I'm not really certain why it's not loading it. I had a little bit issues with this issue earlier, and I'm not exactly certain why. It seemed that before it was having some difficulty loading data. But we can go onwards because the next step I want to add to this shiny flex dashboard is to also provide the option of countries. And we will then see that here. This is another one. Again, I'm just going to add some more options here. Now we're going to build a country list of countries. So we have some country codes to make our selection here for different countries. And here I'm going to have multi-selection, so it's going to be multiple versus before here we didn't have that on. And thereby we can choose more than one country. Now let me see if this first runs, because yeah, maybe we do that. Yeah, I think I'll do that because I think there's something a bit. Maybe let me check something here. That could be no. I'll just try one thing because this sometimes helps. And now let's try. No, it seems it's got issue, but I'll try that a little later once Andreas goes through the Freaksy part, and then we'll come back to this. Where I'll check the code in the meantime to see what's stopping it from presenting, and then we'll continue there. So this would have been the simple Flexboard Shiny option, which I find is a simple solution for making very simple interactive plots. And we're going to now go to something a little bit more advanced, and then we're going to go back to what I would call maybe traditional Shiny. So to put things in context, I have a background in biogeochemistry and worked a lot with particularly water chemistry. And one of the applications that a lot of us who work in this field, especially geochemistry, may be familiar with this app, or this program called FreakC. It's a software that has been written. I don't know how long ago. It's probably back in the 80s, maybe 80s, 90s, and it's a program used to do all sorts of geochemical simulations. It is a massive program. The manual alone is almost a little bit more than 500 pages, where you can do all sorts of different experiments in this program. That being said, it is horrible to work with. The code, the writing style, it's very not intuitive always to how you should write. There's not a clear system always on how to work with this. And it's very much set up that you do different operations, one for solution, one for reactions, one for this. So you have a whole list of these different options, which then provide code. And then on top of it, plotting it is in some way a very not very clean. It doesn't have any of that charm that you find with R, where it's very intuitive to produce ggplots and so on. And to end it all, the plot's basically horrible. They are absolutely horrific to look at. There are some interactive versions, but then again, it's you become limited by the fact that when you work in an interactive environment, then you have the limitations of that interactive environment. So that's why it is great if we could do this in R. And luckily, there is packages to work with this program. And we are going to, I'll open up that now. I will try to put this, we'll load in that FreakC project. So here we are. Now, the situation here is that I am still going to do a little bit of what that old script, the script that you actually use in FreakC does, which is to build these text tables that you saw here. But what we're going to do is by doing it in R, we have some flexibility. We can automate this. We could use this we could run loops, and we could do all sorts of scenarios where we change the concentration of different variables and so forth. And that's what we're doing here. And this is a script that I've put together to demonstrate mixing of two solutions. So we have one solution, and then there's some other parameters such as the concentration unit and charge balance, etc. All this stuff is necessary to then generate some script, which we'll look at right here. If we run this here, I'll make it a little bit bigger. So this is basically, I'm just writing out the script. This is the script we in the end create. We have one solution with exactly what you saw in the in that old manual. So that's what we've created now within R. So we basically printed out this script. Now this is a very tedious process of solving this issue, but once it's done, we have it in place. And then what we're doing is we're using this program in the background, and we're writing some instructions to mix in different ratios. And that's where you can sort of make do your choices, make your intervals, and then you can mix these two different solutions at different ratios, and then get a new solution where you can then look at the chemistry and how it changes. So that is the process there. And the next step is basically to run it. We use the package, this freakc package, where it then takes a database and then it runs it, and it's fairly complicated, but it runs it extremely fast because this is compiled program, so the runtime is extremely fast. And then you get this long table of text, basically a text album with all this information. And then this becomes sort of your limitation, because obviously this is not a great format for you to work in onwards, where you have all the information you need, but now starts the job of extracting this data. So we're going to skip right ahead because that's a little bit of a slower process, but we are going to, if we run the script from here to, so we are going to run, yeah, sorry to hear. This takes a little time because it's got to extract from the text document. There's some NAs, but it's okay. We don't need the, it's for us.
You have to
All right.
mention,
Yeah, and then we have, now we have these data frames, which are now in a nice formatted where we have all this information we require, such as saturation index, sort of indicating whether something, a mineral phase is saturated, undersaturated, to explain whether it would be something will precipitate out or dissolve. And then it's basically pick and choose. We want to maybe look at only aluminium species, so we could filter that like this, and we would get all the aluminium species. So these are all the ones we have. And then from that, I'm going to just take 50% of those species, make a new selection of the species. And this is one for the phase. And again, I'll do the same thing, pick out them, and then we can start plotting, right? We can just start visualizing this here. And we should get some nice visualizations of how, as you mix the solutions, how the species change. And you can do the same thing with, you can also change it with looking at against pH, seeing how that changes, and you get some plots there and phases. And this is a very nice tool to, I mean, it's once you've done the hard work and get this, it's great. You can now, but you can start visualizing, but now obviously if you want to go maybe choose iron, or you want to choose something else and you want to look at that, and maybe you don't want to look at all the species and maybe you want to select, this is where then the R interface and this code becomes a little bit more cumbersome. And maybe also the fact is that if you want to share this with somebody else, do they know how to go into the code and filter out things they want to look at? And then the best thing is to do is you call up your friend Andreas and you say, hey, do you know how to put this into some Shiny code? I have an input section up here, and I have basically some core code that's going in the center that's extracting all this, and then I have some output. Can you put this together? And he'll say, of course, and do the job for you. So I'll let Andreas then go take over and show the Shiny implementation of this script. Thank you.
Thank you very much, Christian. Really nice to get to know a bit more about Flex dashboards. Also, I think it's really nice how compact it is. You can just produce it on your desktop and then you can share it with anyone. And so I think for this problem is also kind of generic, right? That you, Christian, took a PhD. Took a PhD to learn this freakc, the super fancy plotting modulation of geochemistry. I think this goes for a lot of different problems. That a lot of our users, they are really good at doing certain analysis, but then it's it takes many years, but then it's really hard to get it to live on. And I think that's definitely the case for Freaksy. I think this special geochemistry model, I think maybe 100 people in the world, maybe 200, nothing more. And it is maybe the best model, but it's so hard to run. So first, I'm just going to show you the finale. I try to keep, I think Shiny apps, you can keep the same workflow. So now we're going to more Shiny Advanced, as we called it, because this app I would like to go through with you, because I really would love to have an app like this when I started with Shiny, because it's very generic. You just make some inputs, you run a model, and you browse it and export it. That's the flow of this app. So as Christian mentioned, the goal of his script was to mix two solutions and see what happens, and then do some fancy chemical equilibria calculations. And so how this app works is that you get the different parameters, different elements, and you can define them, what kind of input you are, and this is an reactive table, so you can change any value you like, etc. And then you can also give some additional parameters, which is important in geochemistry, which has to do with charge balance. Don't think about it, but you have to give the user the alternative. So then this is the first part Christian showed you, the input part. You can just make the user define what are the starting solutions. And then you can mix it, make the flask shake a bit, shake it like a minute. And so now we're actually behind the scenes running this geochemical model. And now we are at the last part Christian showed us. Now we have all the results in all the different data frames available in our R space, and then we can use Shiny to extract the information we would like to. So overall, these kind of data sets, they both concern phases and species. So phases is more like minerals, right, gibbsites, etc. And this is also quite user-friendly. You can search, right? So you start with Gib, maybe it was Gibbsite I wanted, yeah. But then you're more into the species in the end, because aluminum +3, isn't that the one killing all the fishes? I think it is. So when does it actually stop to kill the fish? Okay, so then you need to mix in, you need to ensure at least 10% of solution 2. That's the kind of dilution factor you have to hit if you don't want to kill your fish. But where does it actually go? You can try to look for the other species. Yeah, I think you see the point there. It becomes very snappy to browse your data set. I think this is the power of Shiny, that you can do a very complex algorithm, maybe some fancy statistics. In this case, it was geochemistry, but you give the user the opportunity to define its own input. You can run the model, and then you can explore the results afterwards. And in addition here, you can also view the raw data which the model produced. And this you can also easily export to Excel if that's your weapon of choice. You can copy it, make a CSV, you can load back into R, etc. And of course, this app, it hides its inputs when you run the model, because usually you want to see the results, right, when you're done with the model. But you can, of course, run it over and over again if you want to change something. Yeah. So, and then everything will update, so it's interactive. So I think I'm just going to show you some bits of how to build an app like this, because I think this could be a very good starting point for a lot of our users. So then I'm taking it back into R, and this is how this app looks like. As an app grows, it's very nice to cut up the Shiny app in different scripts. So by default, Shiny apps can either be written as an app file, then you put everything in one, or you can split the global, you know, the part we wrote in the beginning, in the previous app. You can put it in a separate script called global, where you define your environment. And then you can have the service script dedicated by itself, and the UI where you created your user interface.
Andreas, can you just zoom in a bit?
Yeah, perfect. Thank you.
Yes, wonderful. Thank you.
Thank you, Ro. So what we're doing here, we're going to load a bunch of packages. I'm not going to go into it, but as you see, we have Mr. Freak to the C. It should be here at least. There it is. So that's the package running these advanced chemical models. And then there's a little trick, and that's what we're doing in this line 40. Now we're creating a module called Freaksy, because I don't want Christian's model into my namespace in my server. So I put it in its own namespace. And that's what they called a module in Shiny. There are different ways to use modules, but in this case, I'm using the modules package, which you can see here. So what this line does, it loads in the module I have defined in the freak-C script. So then you can make another namespace with another environment. So if you get package conflicts, this is a great way to handle it, because now we are in a different namespace and it doesn't affect the other stuff. And then it's also nice, you know, if you have two variables having the same name, there's not a problem if you split them in different modules. So here we only have one function defined in this app, and that's the run model function. So you give it a solution and then the charge, which I'll show you the app again because I guess you have already forgotten. So you see the inputs here, we define the constituents of solution 1 and solution 2. We just feed it in, and then the other alternative you can also choose here is the charge, how to balance the charge in these solutions. That's all it's eating, and then it's doing its trick. And as you see, this is just exactly the same script as Christian showed. I just hashed out the solutions he defined in his script because I'm bringing in new ones from the UI. So that's the concept of modules, where you try to reduce the amount of scripts stored in the same. You try to split up your script to make it more manageable and to split up the namespaces to avoid conflicts. So let's have a look at how we created our UI. As earlier, we make a title, and now you can see I use another template, which is called dashboard page. And that has 3 elements. It has a header, and if you see here, that's the header. So I can just feed it a name, which is just 2 pictures, and I can feed it the NGI logo. And then you can also have a sidebar. But in this case, I thought it was better just to have a big screen where you can find the inputs. So I told it I don't need it. And then you have a body. And I think we won't go into detail now, but if you want to do some custom coloring or some custom layout, you can feed this CSS, cascade style sheeting, to tell it how different stuff are going to look. So for the sake of time, I don't think I'll go into that now, and it's not so important for you guys in the beginning as well. The most important thing is to get the data flow functioning in your apps. Here's just some more styling. It tells it how to style the buttons in this table, so it's in the same theme as the rest. And here we also add this fav icon, which is the little icon you can see up here. The little NGI here is a fav icon. And then we can just start to build the page. So now we are in the dashboard body, and that is the part of the page you're seeing here. So first we just put in some, titles. And then I want to split it in 2. That's what I'm doing here. I want to split it 50-50. And then here comes a new one, and that's data table output. And that's a DT table, which will be sent from the server and into this, and then will be rendered on as a table like this, which you can edit. Otherwise, I think you recognized some of the different inputs here. Select input is the same as we used earlier. And then to make the Flask spin, I'm using a function called with spinner. That's what's changing this symbol. Because I'm both asking it to show a special picture, that's the spinning Flask when I'm running the model, and then I tell it to look in the server function to check which picture should be shown. Go and look for the status model output. So I'll briefly show you that afterwards. That's a very efficient way to tell the user that you went from one state, something's happening, and you're done. Because if you don't have any visualization that the model is running, then everyone is going to think your app crashed. People do not like website that does nothing. And then you see we get the action buttons, which is, yeah, I think they explain themselves. It just tells it sends an input to the server that now you should run your model. And now you should clean the table and put in the default values. It's this reset solutions. And then we see that we also have this hide inputs, that's the switch. And then we have the output part. So here is a little trick. because you see that I ask the app to go look for the inputs in the server function, because the choices that you get here depends on the output of the model. If I were to remove aluminum from the inputs, I will not find it in the outputs. So I need to get the alternatives from the server. I cannot predefine it. And this is a very important, or actually it's a really nice thing with Shiny, that it handles this kind of dependencies. Because it's not so easy to program this in other languages. But this is a really strength of Shiny, because it has this UI part and the server part, which can communicate. So, then you have to keep in mind that you have to create your input in the server and not the UI, if it depends on some outcome of your model. Yeah, and I think you can, this is a quite readable code. You get the Plotly output, you get another switch telling that if you push this, it shows raw data table. It should, if that's true, then it's a conditional panel. It only shows if this is true, then it will show the table, and that's the switch you're seeing here. So that's conditional statement for the table showing, not showing. And in the end, we're now once again telling us you cannot sue us if you use this for your commercial businesses and something went wrong. All right, so then I think we went quite quickly through the setup. So if you just look at the server, it is not very fancy. Now it was a lot of things happening here. I think it's hard for you guys to see. You see that the first thing I do, I just define the default. I define the default solutions, and then I make the table. This table input solutions was the same as you see here. No, sorry, it's this table. So I'm just telling it to put the default values into this and show it to the user. But then this comes the tricky part, and this took me some time to figure out, and it becomes quite often important in Shiny apps. Then I'm telling it, please keep a proxy version on the server side. So that means that if something changes in the input solution, if someone, for example, pushes the reset default values, then let's see. If something changes in input solutions, it will set the values back to default. To be able to do this without rendering the data table again, then you need to have a proxy. So then it only sends the new values that change actually. It's a bit complicated, but I'll take you through some more examples. Maybe you'll manage to follow me. So every time you edit something in this table, you edit an input variable. It is sent a value from the UI to the server side. So now I change these values. Now it fired up this code sequence to change the value in the proxy behind the scenes. And it actually, when I pushed enter, that value was sent to the server and was sent back to the UI. So then it is in sync, because that's the tricky part with Shiny. You should have the same story in the UI as you have in the server. That's not always the case. And this is some tricks you can use to keep it the same, because you can easily shift off and have different versions in your server and the UI, and then your user and yourself will be, and your Shiny app will be very confused in the end. So here you see that we just keep track of all the edits, so we can always know what we edited. And then when we push the button called input run model, it hides the inputs. That's what you're seeing here, that we're updating our UI. You are able to change your UI from the server with using this kind of code. So then I'm just telling hide inputs, that's true. So then that will go away. And then we have a status for the model, telling it, are we in the preparing phase? That's when you start the app, you get to the preparing phase. And when you have run it, it changes because you sent a signal on the run input model, and then it changes to finish when it's done. Because when you push the input run model, you also run this code block, which changes the status of this variable, which you have in your server side, to finish. This is a bit complicated, But the overall message here are you make changes to your UI, you send the inputs to the server, you update your table, and you send it back. So you all the time have sync between your UI and your server. And then we can start to, so when we run this model, we get the results as Christian showed you, and we can start to chop it up, and we can have all the elements, which is the first dropdown you saw. So that's the outputs from the model, all the elements we captured, and all the faces and all the speeches. We can start to create those inputs from the outputs. We can start to create the inputs from the server side because we have now the our model available. And so then we can send back to the UI different inputs. So this is a very powerful way to do this, and this function is called render UI. Yeah, so I think this is more of the same. And then, of course, you use these different inputs to use make a selected data set. This is just the same as I showed you in the first app. And then you just feed that reactive function into the different outputs, and then you will land at this kind of interface. So I think we aimed pretty high for this demo, but you need to get to this level to get, I think you very soon need to get to this level to get something useful. So we were a bit ambitious, but hopefully you will find this useful. Yeah, so I think we're running a bit on time, so I don't think I'll open up for so many questions. Hopefully someone is still with us.
I think there's still some people here. And I also wrote down a couple of questions that occurred in between. So whenever you are ready, just give the word.
Yeah, well, I'll just take you quickly through the last part, which is Shiny in production. So I think we'll share these slides, and here are some very useful links to different tools you can use when you develop Shiny apps. We did not take the time to go through them all, but please notice that they are really nice. You can just use Profis for profiling to see where is your code being heavy, where is it using a lot of memory, can you change something? This is also available for Shiny. You can just feed your Shiny app inside the Profis function, and then you'll be doing your profiling. You can also do load testing. You can actually you can make a recording of a user session, pushing different buttons, doing different stuff. And you can play that in and pretend you're being like 100 users on your app and see how well it performs. Because then you're harassing your server, and you can see if you have enough hardware. So this is a bit back to the question regarding how many data points can I have in the 3D interpolation. Well, the answer to that is how much load are you handling in your, how much load can your hardware handle? Shiny logs, it logs every user click. If you want to see how people use your app, how they go wrong, how they go right, you can use this. You can log everything that happens. Google Analytics, you can watch the number of users, etc. And there are also some different tips. If you want to do Shiny, if you want to develop Shiny apps, you should be a bit careful getting a bit into the error tracing, because there are some tricks which makes it much easier. Because if you use a lot of tidyverse and dplyr, it's the errors can be a bit nested. So there are some tricks. So I wrote them up here for you. So I would advise going into this, because you easily will hit some of these errors when you write your code. So this is a way to find easily find where things went wrong. The last part is Shiny in production. So I think we have already talked for quite some time, so I think I'll do this quite brief. But what is production? And Joey Cheng, the CTO of our studio, he did a very nice presentation on this, and he defined it as software environments that are used and relied on by real users with real consequences if things go wrong. So that means that it's not only your R code, the software environment also means that your server and your network, everything have to function together. Usually that means maybe a combination of R code, Python, maybe some Docker containers to build the R software to run it and the operating system. And you need obviously some servers, maybe you do that in Azure. And by real users, often you will have decision makers, as we discussed earlier, which do not know anything about R, and they need this for their work, and that's the consequences. You should not have downtime. Because then you easily get in this situation. Mr. Decision maker, he will observe that everything goes green, and he's gonna call you and ask, why is that app green? It was not green. Green, I say, I made gray. So it's very important to keep a lot of different aspects in mind before you go into production. And we've been working a lot on this at NGI. So Joey Chang, he defines 4 goals when you go to production, and that's keep it up, and that's unplanned outages are rare or non-existent. Keep it safe. The data, functionality, and code are kept away from unauthorized access. Keep it correct. Work as intended, provides the right answers, and keep it snappy. Fast enough response time to ensure user friendliness. Because users, they are not very loyal if things start to go slow. Then they'll leave you very fast. These are the things which maybe differs from how we usually work in R, because it only concerns ourselves. If it crashes sometimes, if it's an update and everything goes down, it doesn't matter. But it does matter when you make a shiny app, which is supposed to work every day in production. Then you cannot handle any versioning conflicts, etc. So you need to do some tricks, and you need to build an environment to handle this kind of error. So the easiest way to get into production, that is to use the free hosting service provided by RStudio's shinyapps.io service. So some of the demos I showed you earlier, they are actually hosted at Shiny Apps. NGI, we are a proud paying customer of RStudio. I think that's also really important, because I think a lot of people think that open source grows on trees. It does not. Someone has to do the job, and RStudio is definitely a very important power in R programming to keep the progress up. So when you use these external hosting services, there are a lot of benefits. It's a very robust hosting environment. You can scale it, and you also, they fix the servers, the updates. You know, they have control of the proxies, so it's safe. So then you can easily meet a lot of the goals you have regarding the goals we talked about earlier. And then it's not very pricey, and you get rid of a lot of maintenance. But the cons are that the integration towards other services becomes more complicated. And if you have a really strict requirements regarding data security, like you want multi-factor authentication to reach your applications, that's not so, I don't think that's possible at the moment. But if you can do without, if you don't hit those limitations, this is a very good place to get started, and you even get to use this service for free if you don't spend so much of their server time. So check it out if you just want to get started. At NGI, we are going to full-blown production in our own cloud. So we have certain requirements for our Shiny service, which we cannot fit our needs with Shiny apps. So what we do, that we put our R scripts in Shiny. We put them in our Docker containers, which is not the topic of this talk, so I'm not going to go into detail. But Docker, it's a platform where you can set up an environment and an operating system to run in a specific way. So it runs. It will be the same wherever you run it. It's a reproducible way to execute your code. So then you know that you will not bump into problems regarding package updates, etc. You can handle that with Docker. You can make it look the same every time you launch code. And then, of course, you need some servers. At NGI, we use Kubernetes. Because of time, I think I'm just going to leave it at that's virtual machines where you can put your Dockers and spin them up. The nice thing is that there's no limitations on how many times you can spin the same Docker container, which is practically just your app. So if you have a user logging on and it's be using all your resources, and another user comes by, you can just spin up another container at another virtual machine. So it's extremely scalable. And it's also really nice because it's auto deployable. So you just push your code and it builds it. I'm briefly going to show you that later on as well. For our internal applications, we just connect to our Active Directory, which means that you don't need an extra password. You just connect with the usual username and password, and then you get access to the Shiny server. So then we don't have to limit the access inside the Shiny server. We just limit who can reach the Shiny server. If you get the difference, it makes it much easier. Word of advice. So we also have another ecosystem which is feeding this our servers with data. I'm not going into details, but we work a lot with chemical data sets. So we capture them, we get them by email, our raw data, we ingest them and we convert them using Python services. And then they can be accessed through this API towards the Shiny server. So our end users, they can see their data through this API. In addition, we also have customer portals. The ones I've been showing you now is only the open portals, which is R&D projects, but we also have paying customers where we also host some applications to run analysis for them. Yes, I have some very few slides in the end. So how do you work when you have a Shiny in production? Well, you usually just work locally as one usually does with R, and you test and you document what you're doing. When you're happy with the new feature you have been creating, you can push it and do your Git. I use Visual Code for this, and then you can configure your Docker. What kind of R version do you want? What kind of package versions do you like? And then we live within the Azure ecosystem, so we have configured it so that the pipelines, which is code, so when it receives a new code in this kind of repositories, it automatically builds it and pushes to the staging server. So that means I just write my code, I go to Visual Studio, I configure the Docker, I do the changes, and I push it, and then I can do my function testing on the staging server. So this is a very efficient setup to be productive. And then if you are happy with your function testing, then you can drag it over to production. This part by splitting between staging and production is really important, because you definitely do not want to push something directly to production. You're gonna you're definitely gonna hit some bumps in the road if you do that. So that's the fun part, that's the building part. So what do you do when you want to run this for many years, as we've been doing now with NGI? Well, you definitely go see your friends. It's really important for scientific developers, especially if you work in R, which is not so known for IT departments, to work closely with your IT department. So we have a core team, and in addition, we have what we call decentralized developers teams we have within the specific market areas. So I work as a product owner at NGI. So I am kind of a glue between the scientific developers and our core full stack developers in the IT development and IT operations. Because you will be, if you don't have experience in putting things in operations, I mean production, you will need some of their experience, because it is quite different to put something in production than just to work as a data analyst inside the R. We also had great help. We did not have so much competence in R inside in-house, especially on the production side, so we got great help from Mapic Consult in the starting phase, I must say. I'm just rushing a bit through because we've been going on for some time. So this is how it works at NGI. We're now going very rapidly towards digitalization in all areas. So R is just one of the tools we use, but we try to make this happy family where you can use the right tool for the right task. Where R is a natural choice for especially maybe chemical problems, while Python, more engineering, and machine learning is in at least some areas more advanced in Python. I just want to point out that this part is often new. The operations and monitoring is not so known, I think, for a lot of people working in R. What we do, that we use Grafana, which is a portal to watch your hardware and how you perform. So then you have all details revealed. I can watch all the logs from all the sessions all my users are running, and I can also get the dedicated outputs from the different services telling me if something's happening. And I can also watch my resources to see if I'm going to hit the roof soon. Back to the case with the 3D interpolation. That's one of the reasons actually we're using Shiny apps for that one, because it can be very memory expensive. It's really nice just to have it outside, because that's just a demo. We don't need it have it in-house. But for our internal applications, we want them to run continuously. Then we need to keep track on them. And another very nice service, we use Sentry. It catches all the errors happening in all your services, and then it alerts you if you reach a certain limit. And then if you get even more errors, you'll get an email from your tech lead, which I did the other day. We had like 10,000 errors before lunch, but that was the testing environment. But this makes you more productivity, right? Because you don't have to go and look for errors. You get messages when you are hitting the roof. So I hope at least you get the overall concept that we just put R inside our tech family. And then we use these different tools to increase our productivity, because often one thinks, I just need R, but you need more tools than that if you want to go into production. Then you need to carefully integrate R into your digitalization digital toolbox. Yeah, so I think if you're interested in more of this, and if you're also doing Shiny production, we are very interested in more friends. So please get in touch with me. I can tell you more about this. Here is, we could talk another hour about this, but I think I'll just go on and finish off. I just want to briefly mention, that NGI are hiring. So please send me an email if you want to hear more. But I think we have a teaser, right, Christian? Because you have the Flexboard Shiny. You want to show it?
Yes, so it's running, as I say, I almost would like to say barely, because it seems to be a memory issue or something like that. And there's, but I will share quickly the screen. I've got it loaded up at least, so we can just see that that last step. Let's see, I have to share again. So I apologize. I'm not actually 100% still certain what's wrong with it, but it has worked after. You may have to mute, I think.
Oh, sorry.
It seems to have now functioned after making a slight edit in the text, and it runs, but it's a little slow. But I'm going to skip the details. I'll put this out on GitHub, and then so it's available at a later point. I've done a few things, which is I did now filtration of, we did filtration by sector, we've done filtration by years, so we've had the input. And we also have, and countries. And then one final thing, which I think is nice, is the maps are, the map that we saw was, it was okay, but it's not a really interactive map. So in that case, I'm using the leaflet that Andreas showed earlier as a, for the plotting, and there you can see the script basically for how that is done. It's basically, we just change out the last part, put the colors in, and then we use this leaflet package. There are some things you have to be aware of, that you must also change it to a render leaflet. So there's a specific function for leaflet, and it's not the same as the render plot. And that goes for, even if you're using Plotly, then you have to use the Plotly version. So it's good to keep that in mind. The result is like this. This is the plot, and now you have this leaflet panning possibility. Now we can go over each country. We see the average instead of just the bar. We can actually see them for individual countries. We get this nice labeling done. We can still do selecting by energy sector, for instance, and fingers crossed it doesn't crash. And there we go. Now we're in the energy sector. Now we get the energy plot. We get the years. We can reduce the years to, let's say, 2009. There's a bit of a, it seems maybe it's a memory issue. I'm not exactly certain. It is a bit slow. And yeah, now the scale has changed here. The time series has changed here. The averages have changed here. And then finally, what we can do is we can choose, for instance, some countries to compare. Let's say Norway and Sweden, let's say. Now, one of the things I have to do here is because if the Annex 1 is still placed here, it will still show all of the maps. So I've done that as an option so that you have to remove this so that you don't get all of them. And then we should get finally, after it reloads, yeah, a little bit zoomed in. We've put some settings in to zoom in to closer to those boundaries. And now we get to see just the 2 maps. And of course, if you want, you can zoom in. We could put up more countries and then, yeah, put this on a website and share it with your friends or with colleagues. It's a very good way to demonstrate, present your data. And it wasn't a lot of code. It was a, there are obviously areas, sorry, let's see. There are aspects of this code that could be probably more efficient with functions. I've just basically plotted things in and put the chunks where I would like them. But basically, you designed your Flex dashboard setup, your outlay layout, and then you've put in basically the code. And it's then this shiny runtime and this shiny library that is necessary then to put in all the shiny functions. And that's basically it I have on that one. And yeah, I guess we're ready for questions.
Excellent.
I think we're going to do the Q&A off the recording. So if you're watching on YouTube, goodbye. Thanks for listening.
Thanks for listening.